Greetings everyone, welcome to a small presentation on my recent work which deals with the observational and theoretical studies of a short plateau type 2p supernova 2020 JFO. I am Rishabh Singh Teja from Indian Institute of Astrophysics and this work is completed with my fellow co-authors. Here you can see a complete poster and it can also be downloaded from Slack or ASI portal. Now I shall take you all to explain in brief section wise. Before starting, just a quick information about supernova. So these are the endpoints of stellar evolution, and depending on the mass, evolution history and other factors, we get different types of supernova. So on the basis of spectra, these are classified into type 1 and type 2. Where the presence of hydrogen, it means a type 2 and otherwise type 1. The ones which we are interested in have constant luminosity for some period of time in the light curve or a plateau in the light curve. So these kind of supernovae are called type 2p supernovae. So this is 2020 JFO which was discovered by ZTF and we followed it up from DOT ARIES and HCT IIA, and this data is supplemented from ZTF and SWIFT UVOT. Here I present our observational analysis. In A part, the multi-band light curve is shown which spans a period of roughly 1 year. We constrained a plateau duration of less than 65 days, putting it under rare short plateau objects where the typical plateau time is about 100 days. Other properties such as rise time, declining slopes and steepness during transition from plateau to nebular phase are also presented here. In part B, the spectral time evolution from early rising phase to late nebular phase is shown. In the initial few spectra, we observed P Cygni profile at 4686 angstrom, and using TARDIS spectral modeling, we confirm it to be ionized helium, which originated due to heated CSM close to the progenitor. There is also some indication of high velocity H alpha feature 36 day onwards, around 63-65 angstrom. Further presence of rare stable nickel and analysis of nebular spectra indicates the origin of this supernova from a low mass progenitor, a less than 12 solar mass. In this section, a preliminary semi-analytical modeling is done to obtain progenitor properties using the model described in Nagy and Winko. So the parameters that we have obtained and details of the model are mentioned in this section. We further move to the fourth section where we perform complete hydrodynamical modeling from evolving a star with various initial parameters to get its light curve and velocity evolution for the supernova. So this has been done in MESA and Stella firmware. The parameters that are used in the modeling and the parameters that we have obtained after modeling are mentioned in this section. Modeling has also confirmed the presence of a secondary radiation source which is in the form of CSM interaction. Finally, some of the results and conclusion of the work has been mentioned here. These include various observational properties, some of the progenitor estimates obtained using hydrodynamical simulations, and the presence of CSM and its confirmation. Thank you for listening. Have a nice day.